Understanding Group 7, Group 0, and transition elements in the periodic table. The elements in Group 7 of the periodic table are called the halogens. These elements include fluorine, chlorine, bromine, iodine, and astatine. They are all nonmetals, which means they do not conduct electricity and they do not have the typical properties of metals such as shininess or malleability. One very important thing to understand about halogens is that they exist as molecules made up of two atoms joined together. This means they are diatomic molecules. For example, chlorine exists as Cl2 and bromine exists as bridge 2. The halogens are quite distinctive because they all have colored vapors and many of them are dangerous and poisonous. Fluorine is a pale yellow gas and is extremely reactive and toxic. Chlorine is a green gas and is also poisonous. Bromine is unusual because it is a liquid at room temperature with a reddish-brown color, and it can easily turn into an orange-brown vapor. Iodine is a dark gray solid, but when heated, it forms a purple vapor. These physical appearances help you identify them in experiments. All halogens have 7 electrons in their outer shell. This is a key idea in chemistry because the number of electrons in the outer shell determines how an element behaves chemically. Since they have 7 electrons, they only need one more electron to achieve a full outer shell, which is a stable arrangement. Because of this, halogens tend to gain 1 electron when they react. This leads directly to an important trend in reactivity. As you go down Group 7, the reactivity decreases. This means fluorine is the most reactive, and astatine is the least reactive. The reason for this is related to atomic structure. As you move down the group, atoms get larger because more electron shells are added. The outer shell gets further away from the nucleus, and the attraction between the nucleus and an incoming electron becomes weaker. As a result, it becomes harder for the atom to gain an extra electron, so the element becomes less reactive. Another important trend is the change in melting and boiling points. As you go down the group, both melting points and boiling points increase. This means fluorine and chlorine are gases at room temperature, bromine is a liquid, and iodine is a solid. The reason for this is that larger molecules have stronger intermolecular forces, so more energy is needed to separate them. The relative atomic mass also increases down the group. This simply means the atoms become heavier as you go down. Halogens can react with both metals and nonmetals. When they react with nonmetals, they form covalent bonds by sharing electrons. These compounds have simple molecular structures. Examples include hydrogen chloride and carbon tetrachloride. When halogens react with metals, they gain 1 electron to form negative ions called halide ions. For example, chlorine becomes a chloride ion with a charge of -1. Bromine becomes a bromide ion, also with a charge of -1. These reactions form ionic compounds, which are held together by strong electrostatic forces between positive metal ions and negative halide ions. A very important type of reaction involving halogens is the displacement reaction. In this reaction, a more reactive halogen can replace a less reactive halogen from a compound in solution. For example, chlorine can displace bromine from potassium bromide solution. This happens because chlorine is more reactive and more easily gains an electron. However, bromine cannot displace chlorine because it is less reactive. This pattern helps us predict reactions. Now, moving on to group 0, these elements are called the noble gases. Examples include helium, neon, and argon. These elements are very unreactive. The reason for this is that they already have a full outer shell of electrons, which is a very stable arrangement. Because they are already stable, they do not need to gain or lose electrons, so they rarely react. Noble gases exist as single atoms, not molecules. This means they are monoatomic gases. They are colorless and non-flammable. Because they are so unreactive, they are often used in situations where reactions must be prevented, such as in neon signs or inert atmospheres. As you go down group 0, the boiling points increase. This is because the atoms become larger and have more electrons, which strengthens the intermolecular forces between them. Even though these forces are weak, they still increase as the atoms get bigger. You can use trends like this to predict properties of elements. For example, if you know the boiling points of some noble gases, you can estimate the boiling point of another by looking at the pattern. Transition elements are found in the middle of the periodic table. These are metals with typical metallic properties. They are strong, dense, and good conductors of heat and electricity. Compared to group 1 metals, they are much less reactive, much harder, and have much higher melting points. One special feature of transition metals is that they can form ions with different charges. For example, iron can form ions with a charge of +2 or +3. This ability leads to another important property, which is that their compounds are often colorful. For instance, copper compounds are often blue, and iron compounds can be green or yellow depending on the ion present. Transition metals are also very useful as catalysts. A catalyst speeds up a chemical reaction without being used up. For example, iron is used in the Haber process to make ammonia, and nickel is used to hydrogenate alkenes. Now we will go through the questions with clear answers. Question: how many atoms are in the molecules of halogens in their elemental form? There are 2 atoms in each molecule because halogens exist as diatomic molecules. Question: where are the most reactive halogens found at the top or bottom of group 7? The most reactive halogens are found at the top of group 7. Question: explain the trend in reactivity going down group 7. Reactivity decreases down the group because the outer electron shell is further from the nucleus, so the attraction for an extra electron is weaker. Question. State the trend in melting points as you go down group 7. Melting points increase as you go down group 7. Question. What is the charge on a halide ion? The charge is -1. Question. Halogens react with metals. What type of bonding is formed? Ionic bonding is formed. Question. Which is more reactive, chlorine or iodine? Chlorine is more reactive. Question. Which is more reactive, bromine or fluorine? Fluorine is more reactive. Question. Which has a higher boiling point, fluorine or iodine? Iodine has the higher boiling point. Question. Which has a higher boiling point, chlorine or bromine? Bromine has the higher boiling point. Question. Would chlorine react with sodium bromide? Yes, because chlorine is more reactive and will displace bromine. Question. Would bromine react with magnesium chloride? No, because bromine is less reactive than chlorine. Question. Would iodine react with lithium chloride? No, because iodine is less reactive than chlorine. Question. Would chlorine react with calcium iodide? Yes, because chlorine is more reactive than iodine. Question. What are group 0 elements called? They are called noble gases. Question. What happens to boiling points down group 0? They increase. Question. How many electrons does argon have in its outer shell? Argon has 8 electrons in its outer shell. Question. Explain why argon is unreactive. It is unreactive because it already has a full outer shell, which is a stable arrangement. Question. Where are transition metals found in the periodic table? They are found in the central block. Question. Give 2 differences between transition metals and group 1 metals. Transition metals are less reactive and have higher melting points. Question. Give 1 use of transition metals. They are used as catalysts.